Hi everyone, welcome to the Community Sync for February 22nd, 2023. I'll cover some of the community stats and updates, and then I'll pass it to Yue Zhang to talk about early conflict detection for multi-writer ECD. So let's talk about the community stats and updates. In the community this month, we had about 250 active PRs and over 75 active issues. We also had just about 61 authors who published 153 commits. The team has been hard at work at getting 0.13.0 pushed out, and I'm excited to say it's getting pushed out today. We would like to thank all the community members who contributed to 0.13.0 in some way. So one of the new features I wanted to highlight with this new release is CDC. This new change data capture CDC feature enables Hudi to show how records are changed by producing the changes. So if you wanted to find the changes between, let's say, commit 2 and 4, you can with this new release. This feature is experimental, is only supported for COW tables with Spark and Flink engines. This new feature supports GDPR requirements where you can now query changes with hard deletes. Finally, another feature I wanted to highlight is the Admin Hudi CLI tool. A user can now use the single bundle jar published to a Maven repository along with the Hudi Spark bundle and start the script to just launch the Hudi CLI tool. This brings ease of deployment for the Hudi CLI as the user does not need to compile the Hudi CLI module locally, upload jars, and addresses any dependency conflict, if there were any, which was the case in prior releases. Shiva also has a blog that will be published that walks you through the new Hudi CLI tool with a sample dataset, and I'll share that in the community and update the slides with that link once it's available. To see other releases and dependency changes, please read the release notes, and again, I'll share that in the community and upload the link here in the slides. If you're new to the community, please join our Slack channel, and if you love and use Hudi, please don't forget to give us a GitHub star. And without further ado, I'll pass it to Yue Zhang, who is a Hudi and Druid Committer, to talk about RFC-56, early conflict detection for multi-writer ECD.
Hi everyone, my name is Yue Zhang, coming from FreeWheel. So this is my great honor to have the opportunity to sharing our new feature for multi-writer named early conflict detection. This is the agenda. I would like to introduce this feature in follow items. First of all is background. Next is high-level abstract. Next, implementation and configuration. Final, I would like to share in a demo to see how this early conflict detection works. So first of all, let me introduce the background. As we know, transactions and multi-writers of data lakes are becoming the key characteristics of building lakehouse these days. In the multi-writer scenarios, Hudi's existing complete detection occurs after the writer finishes writing the data files and before committing the metadata. In other words, the writer just detects the confliction when it starts to commit, although all calculations and data writing have been completed. Of course, which will lead to a waste of resources. So for example, now there are 2 writing jobs. So there is a small job which will upsert 100 megabyte data into Hudi Lake and trying to update the file group 1. And there's another huge job which will try to upsert 5 gigabyte data into the same Hudi table. Also, we'll try to update the same file group 1. As we can see, the small job finished and commits to Hudi successfully. But after a few hours later, job 2 finished writing data files and start to commit metadata. At this time, a conflict can be detected with job 1 is found, and the job 2 has to board and rerun after failure. So obviously, a lot of computing resources and time are wasted for job 2. Fortunately, Hudi currently has 2 important features, which is marker and heartbeat. So a marker can track all the files that are part of an active writer, and heartbeat that can track all active writer to a Hudi table. So based on marker and heartbeat, this RFC proposed a new conflict detection feature, which named early conflict detection. It can before the writer creates a marker and before it starts to write the data files, Hudi performs this new conflict detection, trying to detect the writing conflict directly as soon as possible, and abort the writer when the conflict occurs and detected. So we can release compute resources as soon as possible and improve resource utilization. So here is the implementation. So as shown in this figure 1, here is a high-level workflow of early conflict detection. So as we can see, the early conflict detection is guarded by a new feature flag, which named supports optimistic concurrency control and is early conflict detection enabled. When both flags are true, we could use this early conflict detection feature. Else, we skip this check and create marker directly. There are 3 important actual steps marked in red in figure 1, which is step 1, check marker conflict, step 2, check commit conflict, and step 3, try to resolve conflict. So I will talk about these details in next slides. And first of all, let me introduce step 1, check marker conflict. So as we know, Hudi has 2 ways to create and maintain markers. First is direct write markers. Individual marker files corresponding to each data file is directly created by the writer. And the other one is timeline server-based markers, which marker operations are all handled as a timeline service. So for different types of marker, we must implement the corresponding conflict detection logic based on the markers. Here we design new interface, early conflict detection strategy to ensure the flexibility of checking marker in different behavior. So in this design, we have 2 kinds of strategy. First of all is direct marker-based detection strategy, and second one is timeline server-based detection strategy. So first, let me introduce the direct write markers related strategy. So let's take the strategy 2, simple transaction direct marker-based detection strategy, for example. So this is a workflow for this strategy 2. As we can see, we check marker conflict, check commit conflict, and create marker files in a transaction. So we need to pay attention to the following details. First of all, for the same partition path and file ID, only one writer can check and create the corresponding marker file at the same time to make sure no conflict is missed in race conditions. So we propose to use the existing transaction features to look at the file ID level before checking conflicts and before creating marker files. Please note that in phase 2, this strategy only works with Zookeeper-based log provider, and we also plan to add support of other log providers in phase 2. And as for the simple direct marker-based detection strategy, compared with the previous one, this strategy drops the steps of locking, including new transactions, begin transactions, and end transactions. The advantages are that the checking speed is faster and multi-writers do not affect each other. The downside is that the conflict detection may be delayed till pre-commit stage. So that's another strategy which is still in WIP. Next, let me introduce the timeline server-based write markers related strategy, which is async timeline server-based detection strategy, which is the default one. So this design explains the create marker API on the timeline server. So as shown in Figure 3, the client side calls create marker API, directly requesting to create markers to timeline server. So on the timeline server side, there's a marker check runnable thread, which checks the conflicts between the markers in memory created by the current writer and the marker persists to the storage created by other active writers periodically. If any conflict is detected, this thread updates the value of has conflict, which is used to respond to the marker creation request. So here we need to pay attention to the following details. Firstly, there may be a concurrency issue between reading and writing the same marker file, causing EOF exception. But in order to simplify the module, we return empty result of marker when catch any exception during reading a specific marker, and let the subset checker to make up for it. For example, writer 1 reads writer's marker 0 file, but at this moment, writer 2 is overwriting this marker 0 file. Finally, we get empty result after writer 1 reading writer 2's marker 0. In extreme cases, the delay of early conflict detection will also occur, but fortunately we can adjust the frequency of the scheduler according to the actual situation. So secondly, the marker check runnable only looks at the instance smaller than the current writer for conflict detection. This is to avoid two writers discovering conflicts with each other at the same time and falling together. So such conflict detection logic based on the instance time is consistent with the existing pre-commit conflict detection. The same as direct marker bone filter related strategy for this timeline server based markers is still in WIP, and which will be used in phase 2. So there's another step, step 2, check commit conflict. Why we still need to check commit conflict here? Here is an example. So as we know, when a writer completes writing and commit, the corresponding markers are deleted immediately. In this case, other writers may missing the conflict detection if slowly based on the markers. Let's take figure 4 as an example. So writer 1 starts writing data at time t1 and finish at time t3. So writers 2 starts writing at t2 and at time t4 writers tries to create marker for file A, which already updated by writer 1. Since all marker of writer 1 have been deleted, so such conflict cannot be found in the stage of marker conflict detection until starting to commit. In order to avoid such delay of early conflict detection, it's necessary to add a step of checking commit conflict during the detection. So first we may get and cache all instances before init write handler as committed instance before. And step 2, we could create and reload a new active timeline after finish in marker conflict checking as a committed instance after. And get the diff instance between committed instance before and committed instance after as committed instance during. So step 4, we can read all the changed file IDs contained in commit instance during as file ID set during. So finally, we can check if current writing file ID is overlapped with file ID set during. Okay, as for the step 3, we will trying to resolve conflict. For now, the default behavior is that the write handlers with conflict throw an Hudi early conflict detection exception directly on executors. Before we introduce the configurations, I need to say the scope of conflict detection. So the table service including compaction and clustering are excluded from the early conflict detection, and they can create marker directly with any conflict detection, since they do not depend on multi-writer concurrency control. So next one, I will introduce the configurations. In this new early conflict detection, we added 5 new configuration to control this detection behaviors. Most of them is designed for async marker timeline server based marker conflict detection. Finally, let me sharing a demo to see how this early conflict detection works. So here are 2 writing jobs, which job 1 and job 2. They are consuming the same data files, which named T1 and TXT files, and updating the same Hudi table, which named test ECD. And let's focus on the options. So we use key as a record key, use country as a partition path field. Of course, we enable OCC. We use lazy as a field rights, and we use file system-based log provider as log provider. And finally, we enable this new feature, early conflict detection. So let's run these 2 jobs together to see what happens. Yep. So as we can see, the job 1 is updating data and commit successfully, but job 2, it will detect a confliction in early conflict detection, of course, before writing data files and commit meta files. As we can see, the log here, early conflict detect, but cannot resolve conflicts for overlapping writers. Let's see the first line of this exception. Yeah, here. Error asserting update for partition 0. So which means he didn't writing the data file directly, and he is trying to create macro file and detect this conflict before create macro files and board current writer, which means this early conflict detection is worked. Yeah, that's all. That's all for my sharing, and thanks you all.